Добрый день, уважаемые коллеги.
Good afternoon, dear colleagues. It is my pleasure to welcome you today at the meeting of the Working Committee on Industry, Innovations and Prospective Development within the framework of the International Gas Forum. Well, we stay true to our traditions. Whenever there is a possibility to meet within the framework of a good event, we always make use of this opportunity to discuss any matters or trends that we see and that have been shaped since the moment we've last met, and just to share the news. So this time, we've chosen a topic of digital transformation, a look into the future. And I guess this is the issue that we have been referencing to over the last 2 years, even the years of the pandemic, very actively. I would say every second meeting would be in one way or another dedicated to matters of digitalization, digital transformation, and I would say that is no coincidence. Today, any big company, and I would say that at this stage, there is still a very high degree of uncertainty, rapidly changing environment. The world around us is changing so fast that the goal of digital technologies is to be able to react and respond to those challenges by creating adaptive digital models, as well as potential responses to risk mitigation. In terms of digital technologies, in 2022, due to obvious reasons, we have moved away from the policy of import substitution up to provision of technological readiness and aptitude. This is the move that we've made a long time ago. And this is something that we've been working on for more than a decade. But taking into account the recent developments, I would say that this stream received additional impetus, and the recent event acted as a catalyst to that. Even in the current situation and the limitations to supplies of equipment and hardware from the side of foreign manufacturers, Gazprom continues its work on digital transformation, guided by the principles of uninterrupted technological development. An ongoing technological development, introduction of homegrown technologies provides for uninterrupted operations. From consumer side, it means high reliability of supplies and energy resources, even under the current complicated market circumstances. Digital transformation is guided by the principle of efficient data management, application of digital platforms as a means of digital interaction, and data-driven decision-making process. And that, of course, includes the development of unique digital culture within a company. Just lately, we completed our roundtable dedicated to use of unmanned vehicles. And I would say this is something that we talked about 50% of the times, but the other 50% of the meeting, we talked about software and the use of data gathered by drones. We also talked about all types of package suites and solutions that are available today. So I would say that was a good cut on how it all started with basic monitoring of roads and infrastructure with drones, and is now coming up to indeed a possibility to make data-driven decisions in terms of operations and implementations of investment projects. Digital transformation by Gazprom Group stands for transition to a platform of businesses, and each business is a number of specialized IT solutions and services united by shared information. So we have a number of platforms on employees, assets, management, investment activity, and many more. Within the ecosystem of suppliers, we have a separate platform for production and logistics marketplace. I would say in Russia there are no analogues to that, and the peculiarity of Gazprom allows us to cover a major part of the Russian market, including suppliers of some large haul facilities to the point of their application. And again, I'd like to make reference to the previous session. There was a question asked, have you analyzed the possibility to transport cargo with drones. Well, I would say if it is something not particularly heavy and there is proper insurance coverage, we're open to those options. It's not really a difficulty, I would say, that subjective reality of the last mile that we face. Another example would be that within the ecosystem of consumers, we developed a special gas consumer platform and also service receivers platform, including Gazprom Media Holding and many more companies, including in the Gazprom Group. We also have end-to-end digital services that are there to resolve some specific goals. Those platforms reflect the targeted vision of development of the ecosystem of Gazprom, take into account our long-term vision, uniting all the digital platforms, the ones that we had before and the one that are developing in the future. In doing so, the goals of digital transformation of Gazprom are closely linked to our mission and the strategic goals of the company. The first goal is to make sure that digital technologies provide for higher performance and efficiency of their valuable processes, but also of the products and services and processes in the future. The second goal is about competitiveness of the company through better informed and faster decision-making process. And the third goal is about proactive substitution of import solutions that are not meeting the requirements of sustainable development and maintenance. So within the framework of those issues, we expect that today we are going to have a discussion. As you know, that is a working committee meeting where we always have discussions, Q&A sessions. So your questions are very much welcomed, and I suggest we start and move on with our agenda. Thank you very much. And now I'd like to give the floor to our first presenter, who is Alexandra Slusar. The topic of the report is practical implementations of digital innovations in Gazprom. The floor is yours.
Thank you. Colleagues, good afternoon, and I'm indeed going to give you some details on digital innovations employed in our company. Well, that's true that it did not start overnight. We've been into this for quite some time, and for quite some time we've been assessing the potential of the already employed digital technology and of those that bear some potential. In any event, the decision on whether we use the innovation or not, as always, hinges upon the scalability of the technology. Here are the most promising and the most, in fact, mature technologies. Naturally, this is the big data analysis, artificial intelligence, and digital twins are a big thing for our company. Then the robotization and software automation. Naturally, we use the VR and AR technologies. We employ various kinds of digital assistants, and just like Dr. Aksudin has mentioned, we are using drones, mostly the unmanned aerial vehicles, but not just this. The domain of our operation is too crucial to fail, and the continuity of business processes and operation is one of the major aspects for us. Given the vast geography of our operation, it's crucial for us to stay in control of all the aspects of our operation and be able to respond quickly and with agility. The crucial thing for us is to learn about the risks at an early stage and be able to respond to stymie them as early as possible. And here's exactly the moment which calls for the use of advanced control technologies, something that would help us to analyze huge amounts of data and to make critical decisions. One of such solutions is the innovative industry-specific drill construction center in the Russian city of Tyumen. And they provide, the people who are employed there provide geological and engineering support for construction of development wells and many other services. Currently, we have two 24/7 stations for geonavigation support and four 24/7 engineering support stations. The center experts provide us the engineering expertise necessary to construct the geologically challenged or geomechanically complicated wells and models. By doing so, we are able to forecast and predict the risks. By way of example, here's the technology that allows us to predict the formation of hydrates at the operated fields. And that's an in-house solution of Gazprom Nedra. That's just one example of use of a neural network technology, but the thing is, it helps us to reduce downtime, to save on the drilling mud, and achieve efficiencies elsewhere. Now I'll move to functional capabilities of the current solutions that we employ. It helps us to employ the methods of predictive analytics. One such capability is the system of control for gas pumping facilities. It helps us to track the controlled process metrics in real time and make a decision on whether scheduled maintenance is necessary at any given point. This also helps us to ensure the reliability of supplies to our customers. Digital twin technology is another crucial point for us, and we are using them within a single digital environment. We create what we call a single integrated model of an asset. It is online 24/7. It helps us to integrate seamlessly a variety of different and diverse data about a given facility. It takes as the input the data from a variety of sensors employed on the sensor, and it helps us to apply a proactive approach to the development and operation of an asset. For instance, we are currently using the digital twin technology at the Yuzhno-Ruska field, which is a project of Severneftegazprom. We've completed the pilot stage just recently, and we already know that it drives up the efficiency of the joint development of Cenomon and Turon deposit. It helps us to provide warnings about the GVK liquid level and to prevent other major incidents. Here's another project that is currently being executed at Gazprom Neftekhim Salavad facility. This, in fact, is an entire system of digital tools that are bound together within a single framework. They are employed to automate the processes of scheduled maintenance and repair. In the year 2022, helps us to create a sort of a single digital passport of a facility and to monitor and survey the facilities located in remote areas with greater efficiencies and take all the necessary measurements digitally and remotely. It also helps us to create a registry of industrial facilities at this site. Here's another slide that speaks about the robotization of the diagnostic research of gas pipelines. It provides the necessary level of reliability for the pipelines. So the robot you see on screen is relatively small, which makes even the most complicated sites easily accessible to him. I don't want to create an impression that we are simply digitalizing the production and the industrial assets. Well, it's not quite so. We are applying this kind of technology across the board. For instance, We are using it to train our personnel, so we use all kinds of simulators and AR and VR technology in order to train our staff in the very realistic scenarios, and we're able to imitate the actual operating environment without the need to move people, to have them travel solely for purposes of training. It also gives us a good chance to assess the level of training and its efficiency. Currently, the share of digital training programs that we use is to the tune of 37% in all the amount of technologies that we use for training. During the roundtable, it was already mentioned that we use drones for aerial surveillance and for visual control of the condition of pipelines. And like Mr. Ksutin mentioned, we have our own in-house software for tracking the situation along the pipelines almost 24/7. We can clarify any deviation from the pipeline axis. We can quickly detect any minimal distance zone violations and to track the amount of trees and bushes around, trees and shrubs around the pipeline. In terms of efficiency, it gives us another clear advantage. We are reducing the costs of collecting data, since what's the alternative? You have to use a helicopter and actually a crew of people. So that's much more cost efficient. And it gives us an opportunity to drive down costs, not just at the already operating facilities and fields, but already at those that are under construction right now. It's also critical to employ this technology at the stage of scenario modeling, because it gives us a chance to streamline the cost structure at an early stage. We have an in-house digital assistance, GRR, which helps us to streamline the project portfolio, the project pipeline, given the specific purpose and restrictions. We have been developing this tool using the domestically developed software only, so it's completely sanction-proof. And one of the most promising ways of employing digital assistance, since we're talking about the future outlook after all, is the digital assistant for the investment block of the company. It helps us to factor in the somewhat complex and challenging factors. We can factor in the ESG and create a mathematical model for streamlining the optimal performance of a given investment project. And as the parameters of the project change on the go, we can change the model on the go. It helps us to streamline the efficiency of gas supply mathematical models. And it's true that it's but a small share of the opportunities that such technologies provide, but I hope that I was able to give you a glimpse of what we are working at right now. If any questions, I'll be able to ask them. Thank you, Alexander. Colleagues, do we have any questions or comments? Yes, please, gentleman on the left. Mic, please, to the mic, please. Marat Saifulin, the Machine Building Institute at the Russia's Academy of Sciences. So I've got a question. Do you have a solution or perhaps a ready-made technology for assessing the state and status of the wells, the gas wells, oil wells that are, located at a certain depth? I think it's a challenge for both gas and oil and gas people. Well, Mr. Slusar is more about the IT thing, so I think I'd help him out. That's, a bit above the pay grade, so to speak. So I'll help him out. I would put it this way. We do have solutions at the moment. They're not employed en masse. They're not that scalable, but we have pilot projects. Take the city of Orenburg, for instance, where we have a specific site wherein we are using a technology of IoT, the Internet of Things. So that's a sort of a chipset installed within the well that helps us to track the status of it 24/7. So half of the task is to collect the data. Then you have to analyze them. But if you think about the sheer amount of the fleet of the wells and the amount of chips and the amount of sensors that would be necessary, well, it's a whole new level of difficulty. So we do have solutions, but those are sort of tailor-made for a specific project. How do we scale them up? Well, that's the challenge. We have also executed a project like that at Severneftegazprom, a subsidiary of ours. So the solution was something like that. We created a digital twin of the entire factory, of the entire facility. So it covered both the prospecting, the engineering component, and the, so to speak, economic component. So this is an undergoing effort. We have covered major ground there, and the operator is now able to collect the data generated by the AI and analyze it. And by the way, it does employ methods of predictive diagnostics of the well condition. So it's a bit like that. Any more questions? Yes, please, gentleman, straight ahead of me. Zapsibgaz, Sergey. Mr. Slusar, thank you so much for such an extensive report of the grounds covered. I have a very specific and perhaps a narrow question. It goes a bit beyond the matters of control, of IT and something like this. It goes like this. It's the work with the contractors. So the question would hinge upon the theoretical underpinnings that you use in your work. So what's the theoretical basis of your work? So let me elaborate a bit what I mean. You are probably aware of the so-called SAS system, which failed at some point in time and was discontinued. Why has that happened? Because the so-called economic theory underpinnings of the national economy were wrong, were misplaced. So right now we are challenged by lack of efficiency. I think that our Chinese friends actually use the right amount of theory, and they coupled it with Lin's theory. So Russia attempts to automate its various domains of its industry and employ the Lean philosophy, often fail because this is an Oriental philosophy, and it often fails and that creates inefficiencies. So now we have something different. We have counterintuitive technologies for labor productivity boost. Well, you're all aware of these stories about the Chinese skyscrapers that are built within 360 hours. So if we try to project this experience to our domain, we had the productivity increase to the factor of 5, which is quite a lot. So the question I'm trying to formulate is, what is the theoretical underpinning of your work? Do you use some kind of academic underpinning? You know what? I think I wouldn't be able to answer you straight away. I'll find you after the conference, and I will either give you my email to follow up with with the reference materials that we use. But let me put it this way. You managed the lean production technology and all of this sort of Oriental technologies. We've tried them all. we've tried to employ them, we've tried to be agile, we've tried to be lean. But you do have a point when you say that when placed in an improper context, this technology wouldn't work. It just won't take root. So the digital transformation proper is but one domain, one area of creating new business models. It's just one way of looking at things. And the cultural transformation and the cultural exchange and the exchange of experience is one of the key components. And yes, we try to instill the right culture within the company. That's part of the plan and that's part of the process. And the things that I mentioned, the digital twins, the ways to track the well condition, are the tools that help us to find our way towards the optimal modus operandi, towards the optimal way of work. But it's not that simple. You cannot do it in leaps and bounds. You have to move through certain stages in a step-by-step basis. So yes, Chinese have been able to do it quickly and efficiently. It doesn't mean that we would be able to replicate the experience here. So I'm sorry, but I won't be able to answer your question right away. I will follow up on this. I think it's the operative word here is contractor. You mentioned that the question is about the contractors. So there's a hitch. There's a tricky part. We can adopt, how should I put it, a country-specific approach or country-specific attitude, but that would be too much of a generalization. We should look at any contractor specifically, and we can make a distinction between our contractors. First is the Gazstroyprom, one of our major contracting bodies. It's a company that helps us with many aspects of our work, with overhauls and many other things. And then there are the individual contractors, the individually formed contractors. It would be hard to compare them side by side. The internal structure, the culture of the company, and all those things, the performance eventually depends on the level of training of the company management, of the goals that they pursue, whether it's a long-term value thing or a one-time benefit. So as we were trying to transform the investment block of Gazprom in 2019, we have looked hard at issues of digital transformation, and we tried to initiate similar processes among our contractors. So it was not the standalone project within Gazprom proper. We've tried to project it, as it were, to the entire ecosystem. And believe me, it took hours and hours of conversations between us and our contractors as we would try to reach out and explain what we mean and explain what kind of culture we're trying to build. And it's a work in progress, I should say. Some of the companies made their own contribution to the process. Some of them acted up on our proposals. But the thing is, oh, and by the way, we have changed the project management system. It would be delusional to believe that we all share the same working culture and working ethics. Even if they are our contractors, it doesn't mean that we can, by a wave of a magic wand, to do what we want to do and how we want to do. But as we progressed with the digital transformation and with making the 2D drawings into a 3D model, we saw some progress. I think it took several months, And I remember one time I was asking, well, do we have a 3D model of the construction site? And the guy I was talking to, he said, oh, that. Well, we forgot that. We forgot that we need that. So, you know, all these hiccups, they happen. The most recent case in point would be the Kavikta site, where we try to reduce the deadlines as much as possible to compress them. So, you know, the white helmets, the foremen, well, they use them. You wouldn't believe it. It's, you know, the hardcore oil man, a gas man, and yes, they would use these tools. So, in this sort of a roundabout way to answer your question, we have to change culture in order to change the mentality, in order to change the system that underlies it. I hope that together we were able to address your question to some extent. All right, colleagues, we are moving on, and the next speaker in the lineup is Yevgeny Zakrepin, Vice President of Strategic Development, VP, National Computer Corporation. He will speak about immediate prospects for the digital development of oil and gas and the current realities.
Good afternoon, dear colleagues. My name is Yevgeny Zakrepin. First of all, I'd like to express my gratitude for the possibility to participate at this event. This is indeed extremely valuable for us. As I was just told during the lunch break, Gazprom is a very serious company with long history and deep-rooted traditions, so I'm doing my best to stand true to those traditions. So within the framework of my presentation, I decided not to stay so close to the presentation as I initially planned, but I'd rather like to share a couple of thoughts and then illustrate them with the slides I've prepared. In the last 2 weeks, this is already the 5th conference that I'm participating in, and I can tell you that well, maybe some of you have experienced problems with digitalization after February 24th, and there was a certain shock with some companies. But I would say that in half a year, virtually all the companies have been able to overcome this shock. They've analyzed their IT landscape. They've clearly realized that IBM, Oracle, SAP, I don't know, you name it, have left the Russian market. Mentally, people have had to get used to that, to accept it. Companies who worked for 5 or 7 years with IBM or Cisco, it was very clear how those integrating companies used to work, you know, all the rep offices, you had contract signs to millions of rubles, and after February 24th, unfortunately, they were just paper, nothing more than that. One of the ways to react would be to sit and stay shocked, and the other option would be to think what you can do about it. And we have approached this situation in a certain manner, and this is exactly what I'd like to share with you today. We were guided by the principle of digital transformation, and our motto was very well conveyed by many business schools earlier, and it fits very well in the current situation. So the first key principle is digitalization for the sake of digitalization was always meaningless, and it's still the same. So if there is a solution that a customer needs, if you introduce some technology and you see that the revenue is growing, that means that you're doing the right thing. If it doesn't happen, then it is absolutely useless. So you need to understand clearly what is it that you're offering to your customer. On the other hand, about 2 years ago, I studied at the MIT. I took classes on AI and machine learning. I was very excited about it. I realized that there is nothing scary about it. Back in the 50s, many of the Russian scientists have come up with a number of algorithms that are used to this day in these technologies. But an important point to that was that every company, be that Gazprom or any other major structures, should be aiming for the so-called concept of digital master and being the digital master, master of digital transformation. Because the criteria defining a company being a digital master or failing to be one is to make sure the highest gross revenue per capita and the highest ROI at the same time. That would mean that the digital transformation that you are doing and the steps you're taking are the right ones, and that would make you a digital master. So if we look at our company, in terms of commercial market, that is a private company, quite a big one. We have about 4,000 employees. We've been in the market for more than 31 years. We've been through a whole number of crises, 2008, 2014, and counting. But the peculiarity of our company is that we were preparing for import substitution well in advance, and the companies that are listed on the slide are all acting either as an integrator, introducing some major projects for banks, telecom operators, oil and gas sector, large state enterprises, or those companies are acting as vendors, offering Russian-made products. We're just coming ahead and anticipating that there would be a moment when all the Western products would have to be substituted by homegrown. We saw some new shareholders joining the company, namely those are enterprises, owners of the products produced by Astra Linux. I guess many of you know this company and are aware of the stack that they are offering to the market. That includes Rusbitech company. I should also mention that Gazprom is producing a lot of R&D projects. And those are the companies to the size of about 1,500 staff that are doing all types of R&D projects. And I think that creates a lot of potential synergies for cooperation between our company and Gazprom in terms of product development. So what I'd like to emphasize now is that we have a very simple approach to working with our customers. We consider ourselves to be a vertically integrated structure, starting with some basic things like server equipment and storage solutions used by Gazprom and many other companies. We are also suppliers of Aquarius hardware that initially was part of NCC company. So again, whenever we would see that there is a necessity to use only those solutions that are registered in the Russian registry, then we would always use suppliers of Chinese hardware, but this hardware should never be supplied to the European or US market. You can find hardware like this, so the customer may choose between the Russian registry and good, solid manufacturers of hardware, or some Chinese hardware that is also available in the market. I should also emphasize that if we analyze and go up to the next level and analyze the situation in terms of infrastructure solution, everything related to software, obviously before everything was Microsoft and Windows driven, we are promoting Astra Linux solution, and our customers, likewise, no matter who we talk to, later we talk to Force Agro Corporation, one of the largest fertilizers manufacturer. They use various operating systems, including our Astra Linux system, for their development. So there are solutions available in the market that you can use. Probably they were not that convenient as the ones of Microsoft, but they are operational. Be that VDI from Termidesk or Office Suites, they are capable of resolving the tasks and goals that our customers are facing. And just like Gazprom, they can include it in their roadmaps, plan for their development. Many of those solutions have already been tested. Gazprom included, they are eagerly piloting those solutions, and afterwards they bring it to operations. Just a side note here, whenever we talk about digital transformation, we mentioned the use of unmanned aerial vehicles earlier. And just a year and a half ago, we started talking about digitalization in machine building, and in a year we probably created the best practice in terms of PLM solutions. And from the very beginning, many of our structures, be that Russian helicopters company or Roscosmos enterprises, were actively using solutions by Siemens that allow you to do a lot of tests and developments with drones. So we managed to put together a team that is truly the best team on the market that worked on the introduction of Siemens product to Russia. And I frequently like to draw your attention to the fact that SAP keeps working in one way or another, and people know how to maintain it in proper operational manner. Likewise, Siemens licenses are still valid, so we have some time to move away from a product of this very respected company that has been in Russia for 300 years to Russian solutions. And there are those solutions available. Those are full life cycle system solutions, and be that any conference, and parallel to that, there is a conference going on in Perm right now where they discuss import substitution, and everyone keeps saying they developed a P&L system for various classes and solutions like that. We are also participating in this process, and we see that solutions available now are acceptable, and they allow big enterprises to bring their products to the market from the scratch, and they do the proper design stage, then move over to digital manufacturing and operations. So from my side, I do see that such a big and important company like Gazprom can find the necessary level of support from ancillary industries that are affecting your business processes. So rest assured that we have the right digital solutions that will allow you to pursue your goals. So we are fully complying with this trend. Obviously, many things relevant for digital transformation are affecting means of engineering and technical support of security equipment. Back in 2010, we started discussing the matter of smart city concept, and we were well aware that there are a lot of borderline situations possible. We talked about environment, we talked about carbon footprint, and nonetheless, many companies are paying a lot of attention to matters of environment protection, and they remember the experience of Norilsk Nickel and the major incident they had. Well, we have been working on this matter for a long while, and we have developed solutions that allow us to take care of environmental monitoring, for state agencies or even on the level above state agencies, that allows you to understand that you can take care of environmental security, public safety, road safety, and many more. So those are those cross-cutting solutions that we can offer that can allow you to eliminate some irrational problems when the report says that everything great, but then something happens and it turns out that it was not so great. And when you start looking into that, you can see that that may be a cross-cutting issue, and you may see that some of the departments fail to coordinate the actions properly, and as a result, there is a major incident happening. Again, speaking of the Russian products, I'd like to mention an IT product we have called In1. I'd just say a few words on that. That includes around 270 CCTV cameras installed all around Moscow. We also can provide monitoring in Krasnodar regions and many more. Likewise, this platform can be used to monitor about 5,000 refrigerators used by supermarket chains, whether there is proper maintenance provided or any maintenance needed. So IoT platform is a good trend, is a product very popular on the market right now, and this is an IoT platform that is solution to many projects we have that require certain solutions to security matters and collecting data from sensors and CCTV cameras, and this is exactly what you can do with In1 solution. And if there is a possibility, we'll be very happy to discuss this solution with Gazprom in more details. One more good product we have is called Russian ERP platform, and we have very positive attitude to 1C solutions. We have our own team that worked on IC implementation and Galaxy product. Those are the very same people who worked on the introduction of SAP to Russia. But there is an alternative product that we purchased from Brazil about 8 years ago. We have rewritten the code pretty much, and about 2 years ago we included it in the Russian registry. So the approach is simple. It has to be a software written better than SAP. It has to be properly piloted and tested, and indeed all of the South America is working on this solution. We adapted it to the Russian market and are now positioning it as a Russian product. Many are tired of 1C, of a certain positioning you get from it, and are looking for alternatives. So now we work with a number of big companies and are working to turn this solution into the foundation of their ERP platform. One more solution that we already tested with Gazprom and is gaining some positive feedback is a BI platform called TriFly. It is a bestseller on the market, and there are many various companies using it. I'm confident that Gazprom will also like it. So you can easily use this BI platform, but that is also a decision-making tool, basically, for high-level managers and the management of corporations. So once we started implementing it with Roscosmos, obviously the company includes a lot of enterprises in the group, difficult accounting and reporting processes. So we started integrating it all together by integrating it with BI, with financial analytics and reporting. And later on, this platform became a market standard and is now applied to all the enterprises working within the group. So this system, this solution is so adaptive and so flexible that you would find it on the table of many governors, many subjects of the Russian Federation at various ministries. They like it. It is quite reasonable in terms of pricing and provides you with a lot of flexibility. And there are many cases of where it is being implemented by the General Prosecutor's Office and many more. But the key idea of this approach is that it can be actively used by various customers and provides a lot of flexibility. We also pay a lot of attention to analysis and optimization of business processes. There was a product called Celonis. It was a market standard in many structures, primarily in banking companies and some industrial enterprises. It was also actively used by Fossagro before. It was a good system, providing you with analysis of business processes and ways to optimize it. From our side, we've realized that it is necessary to move on. We received subsidies from the Ministry of Digital Development, and we as integrator enjoy working with the Russian government because we really do receive support from them. We receive subsidies, and subsidies allow us to develop very fast. And process mining is exactly the product we developed thanks to the subsidies of the ministry, because we knew that we had to develop a product better than the ones available in the market. The same applies to a product called Simple One, and that's a service desk. Again, we sell this product successfully and develop all types of monitoring solutions. I should also mention a separate product on automation of RFID tags. We have around 1,000 projects implemented in total. We have our own production of RFID tags, so everything related with labeling and tagging can be done by us. So those are the key topics that I wanted to convey to you today as representatives of Gazprom and potential partners. So we're looking forward to long-term partnership, and we understand that working with you means working for real and really dedicated to this work. We're ready for that, and we are interested in development of our presence with Gazprom. Thank you very much. Thank you, Evgeny. Dear colleagues, any questions, any comments? I have a couple of questions, if I may. Evgeny, thank you very much. Indeed, you represent a big and exciting company. Obviously, there is a big value that you present with your expertise in the country. But would you please comment on what the companies of the ski group could do? Do you have any kind of strategies regarding implementation of the Decree 166? Do you have any thoughts on that? Just to remind you, you probably know, maybe some don't, but that is a directive banning use and application of cyber-physical systems and software and even hardware. Well, indeed, you've raised a very complicated issue. It was easy to write a law, but then all the companies ended up in the situation where they are today. Well, the general rule here is you have to cut an elephant into pieces if you want to eat it. If we talk about the use of software systems, I would say there are operating systems available, Astra, RedOS, Linux, and this is something more or less properly developed at the moment. So the companies will be forced to start using those solutions. They don't have much of a choice here. We obviously understand that in terms of use of hardware solutions or storage systems, we all understand that there are basically 3 companies in the world producing hard disks. So if you would tell me that we need to develop disks of our own, I would say we should not. It doesn't make any sense. Hundreds of millions of US dollars of investment were needed in order to create it. But anyway, we will not be able to keep pace with the market. We would always be worse. And having an understanding of all the limitations, we would know that the spare parts and components would be brought to the Russian factories. They would be assembled here in Russia. And Vasily Shpak, who is responsible for that at the Ministry of Industry and Trade, would read us a lecture on what is going to happen in the future in terms of service and storage systems and how they would develop in the future. In our group of companies, likewise, we had a processor you probably know called Baikal, or the one we have now called Elbrus, when you're forced to develop Russian processing units. Certainly, February 24th was a very hard hit on all those matters. How can you do that when all the spare parts, all the elements and components are imported? But nobody is giving up. Yeah, including the crystals for the processors you mentioned. Yes, you're right, they're all imported. So, like I said, we have what we have, but at the same time, what I like about this approach is that on the one hand, people at the Ministry of Industry and Trade understand what is the way to go, and we do receive certain support from them. We receive subsidies for development of those solutions and creation of those products. They hear us. We ask for help and we receive this help, and we get things done in terms of critical infrastructure and hardware. And it's no secret that in terms of digitalization and automation, you are forced to focus on applications and applied parts. Even when we started developing Astra, I was explaining them where we should work together and where we're getting those synergies. You would get a monitor from Samsung, a keypad from another manufacturer, but at the same time, the key thing is what is the platform that the customer is using. Whether it's Astra or something else, Intel or other provider, they don't even know. The key thing for the customer is to make sure that you provide you with a functionality that is vital. And it doesn't really matter whether it's Gazprom or any other state enterprise or something else. So the key approach here is, again, cut an elephant into pieces if you want to eat it. Well, I would say that IT experts at Gazprom should really make a fuss out of that, saying, hey, how come it doesn't really matter what is the microchip you're using when we talk about automation of our facilities? We have a state directive, and according to that, by a certain deadline, we are to provide for specific actions. And if those actions are not taken, then starting from a certain period onwards, from the management of the company and later, certain penalties would be imposed. So I don't know. So it is important for us what is inside, what is the microchip you have inside, and we are to report to that. We're responsible for that to the government because we are a state-owned enterprise. We received a clear instruction to get this and that done. We understand that very well. So everything that can be done, there is being done, but there are certain risks, and that's a reality. Well, I don't care about the reality. You have to proceed from the context. Well, I'm sorry, but everybody's talking about solutions, but are not explaining how they're going to implement those solutions. So what is the situation we face? When we've been to Kazan, I was saying, what is it that we're facing today when we talk about supplies of hardware to our projects? Colleagues used to call themselves Russian manufacturers. They were swearing on the blood. We are a Russian company. We produce in Russia, 100% localized. But once we started checking that, it turned out to be completely different. There is so-called import of the second and third level, and it's all about components. It doesn't change much in terms of configuration of the hardware, and I should say that the manufacturers are doing great in finding solutions and alternative solutions by changing their offer very quickly, by finding substitution here in Russia in some elements and components of their hardware. But we see what's going on, and if we are to say, oh, don't look what's inside and under the hood, just take it the way it is. Well, Intel is in Samsung, Intel is everywhere in automation systems for technological process, or if it is Intel processor inside Samsung, well, that's very different. You know it well. So I think we should be open in saying that, yes, we are going to get it done, because Gazprom is providing market for all those solutions, but on one condition: it has to be Russian-made, and it has to be properly applied. And it's all about application. I understand there are many technical and technological questions in terms of production, and it's good that people understand how to do that. But I'd like to reiterate, it's not going to work like this, like, we'll do something for you, but don't look under the hood. We are going to look under the hood. More than that, we developed this system together with a state structure that is instructing us to look under the hood, and we are going to do that. So if you're going to have Intel under the hood, it's not going to work. If we're talking about something more serious, well, today we are going to have one company doing a presentation, and I will ask my question when we get there. But I think the truth is somewhere in the middle, really, be that Mr. Shpak or Mr. Zarinian or Shadaev. We probably need to develop systemic and comprehensive projects to make sure that we develop this war mode, and in inverted commas, of course, or probably not, but if that is Gazprom, then it has to be real and proprietary and really Russian-made. So you have to be wise in how you act. You have to be smart and sensible. But we need to realize that the world is getting severely polarized, and all the means that are there will be used against us. So we have to be aware of it. Well, in fact, Gazprom has a strategy how to react to that. We conducted analysis. We've done our assessment, and we understand who we are and what we have and what we need to focus on. And there are different stages in this planning: midterm, short-term, and long-term. And we know for sure that verification and visualization of those tasks is what we do, and we stick to that. Clearly, we can't refuse from everything in a day, but at least the vector of development is clearly stated. All right. So under these circumstances, we need to stick to those goals that were set to us by the Russian state. We, as users, need to make sure what is it that you develop. All right, dear colleagues, any further questions, any comments? If I may, I wanted to add something. I know that there are external circumstances, but also conditioned by internal challenges. So I wanted to emphasize that whenever we talk about protection of technological sovereignty, we are even more rigid in that than the requirement of the official authorities. It's not that we are guided by the recommendations of the Ministry of Digital Development, but we also have our own regulations. We are forced to move over to import substituted solutions, and within the framework of our presentation, we've seen a number of systems and digital solutions that we have tested already in one way or another at various enterprises. And my question is related to the following. Irrespectively of the fact that we need to move away from sanctioned solutions to the Russian solutions, among others, it is very important for us to pay attention to the matter of convenience and efficiency of those solutions so that we could deliver on our goals. And unfortunately, not all the solutions presented here and solutions that we know of are compliant with those criteria. In your presentation, you've mentioned it, that it's great that the government is providing subsidies, and Mr. Aksutin stated that we are shaping the market. There is a demand. How do you think what else should be done in terms of that type of systemic approach so that our enterprises and Russian manufacturers would not be just selling what they already have, and unfortunately, very frequently, it cannot be considered equal to the solutions that we could only get from Western suppliers, but would also work to improve quality and performance in terms of application of their solution in industrial processes.
Well, our main issue right now are the people who need to be on board with us. So the team is the main issue. So we took 35 people from Siemens, and so that's not a secret. So we actually surely need this Western experience. We need the teams that have the experience, and we try to build and use this experience through the teams that came through from other companies. And we all know the setting of the set of the necessary goals, and we don't need to really copy, but we need still to be one step ahead, so that our program would be adequate in the coming years. Yes, surely we need to just copy. This is not about the creation of analog. Otherwise, we would lag behind forever. This is why we don't use the term of the import substitution. We just try to be independent from the Western technologies. This is exactly the talk we have with the ministry. We try to show what we can do, and we work for the future. We try to develop software as such. Sometimes it's not an issue of the finances. Sometimes it's hard to find people. Thank you. Any other comments or questions to our speaker? So we move to our next speaker, and this is Mr. Evgeny Gengrinovich, advisor to General Director of Infotex Company. Thank you very much for giving me the floor. Well, my report is it kind of follows the discussion that we had. In December 2021, the strategy for digital transformation in Gazprom was approved, and the key factor that it targets is the safety and performance of the production sites. So soon we'll have the situation where the performance of all the technological procedures and processes will be inevitably connected with information and cybersecurity. So what we have? We have the whole range of different natural disasters or natural phenomena we cannot fight with. They just exist. We just need to take them into the account. We already have some instruments like the lightning rod or the barometer, and those instruments, they cannot prevent the natural phenomena, but we can work through those natural phenomena and disasters. And the same is with digitalization. We know that all automatic systems and management systems, we usually work for some 20-25 years. And I won't be talking about the development and the trends and in digitalization. We see how it develops in exponential. We don't know how how the field will change in 5 and 6 years, but still we need to operate the systems. So, what should be the approach? We don't try to forecast, but we try to estimate what are the key factors that will influence the reliability of systems. What are the factors that can lead to some changes, dramatic changes in the systems? Well, I did a kind of a comparison between the external and variable factors that can influence the business. Surely those are natural disasters, this is a human factor, also the physical failure of the equipment. This is all possible. And as for the digital world, the scope of problem is different. We also have the software bugs, we have different misconfigurations, we have unauthorized access, both because of the mistakes or for some other reasons. When we look in the details and try to analyze the reliability of digital management systems, we always see some key areas. These areas, they influence the general reliability and operability of the system. Let's look at the international arena and the experience that is already gained. The main approach now is the security by design approach. When we look at the whole life cycle of a process, and we try to estimate the key risk factors that can influence the process. Well, on our side, we cannot interfere with the work of developers, but we can give some tools, the ready solutions that can help to analyze the possible issues on all stages, on all parts of the process. So what are the solutions? The reliability of the system is very difficult, multi-layered process. For a couple of years, we've been working on virtual infrastructure creation. The United Data System for Gazprom has been implemented several years ago, and it has been in use for quite a while already. And we have developed several solutions from that time. We now have the possibility to work with different clouds, foreign clouds, and also the one that were developed domestically, like Yandex Cloud. And now we can use not only the physical objects, but also virtual tools that kind of modeling the physical objects. What also has been done, we did a lot for the integration of the models with the primary devices. We already tested the solutions with VAGE, Siemens. We already have solutions for drones and IP cameras. We also have solutions for transport solutions. For example, we worked with Kamaz and some other manufacturers domestically. So you have a universally applicable environment where you can implement different other projects. So this is not a new environment. This is something that's already been tested with some major companies. We had implemented our systems both on railways, in smart city technologies, in telemedicine. What is important is to say some words about the devices themselves. Now we have the physical controllers with the possibility of encryption with the ready IPs. What are the benefits? The faster development of the controller, and also there is no need to certify on different levels of this controller, because actually without the API it's very difficult to certify certain controllers. We also carried out the work for the standardization of solutions so that they would comply with the governmental regulations. For example, we already worked in accordance with the decree on encryption protocol for industrial application. CRISP, this is a kind of encryption protocol for industrial application. It helps to fulfill the interoperability of different systems. The system has three different parts. The sensors of the management system, and then the upper level that unites everything in the service application. Here you can see the module for the integration with every industrial controller. The module is passive as the whole system. It can be integrated using several interfaces and using the simplest API, and so that the developer can easily control and carry out the identification. So basing on this solution, you can do every type of the access solutions. As for the software, it can be integrated so that all the data can be checked and then deciphered. Why it was necessary to have the standardization of the solutions? For such systems, it's important to have the minimal overhead, so that when we identify the data, sometimes we have the issue of too many data and too many processes. So for us, it was important to have the minimal overhead and the high performance. And also, it was very relevant to have the certification ready, so that every user didn't need to certify the end solution. As I already said, the integration with other producers is quite easy. I would also like to mention, well, it's already was said about the microchips. Now we have the third-party microchips. They are not domestically produced. We now work with a Micron company. We do the tests in order to use the domestically built CPU. But it's just a question of time. Right now, we also are working on the new version of our system with crypto chip. And now we are using on the solution for the households. Our typical solution is too expensive for the domestic use. So now we are working on the crypto chip with CS Core Nano, and the chip is so small. This is fully domestically designed, and it's managed through this same solution. It can be worked together, the CS Core with crypto chip. So here you can see the examples of the usage for the industrial IoT. We are now piloting this industrial IoT network in 2 departments of Gazprom. The integration takes time. As for the MSP model for IoT, this is the centralized management platform where where all the management tools can be allocated to the branch that will only manage the data. During the discussion, there was a question about how we can develop such solutions, how we can integrate them easier and scale them up. Well, our company also takes part in the discussions at the Ministry of Industry and Trade. And I believe now the main challenge is the following, that we actually, as the software designers, we work a lot with manufacturers of microchips, of processor units, and all the hardware. So what is the challenge? In order to use only domestically manufactured components, we need a good dialogue between those 2 parties, software developers and microchip manufacturers. We need to have some planning, as it was in Soviet Union, for example. Now, within the association that we are part of, and we have the program that's called the Vertical Project. What does it mean? We have the certain technical task from the companies, and then the scope, the number of companies that will work on this project. This is a good idea, but what they see now is that sometimes many companies, they actually they're not ready to invest in such projects because they don't really understand what is the target, the goal of a particular project. We need to all to pay for those risks. We need to have the service model, and we need to work together with hardware designers and software designers so that we would understand the whole scope of projects that are now existing. And otherwise, the consumers, the customers, they don't really understand how we can work all together. Only through thorough dialogue, through the good communication between all the interested parties, including integrators, we can really work with domestically built components and create our own software. Thank you very much. Are there any questions or maybe comments? We have time for discussion. Well, probably the discussion will take place during the coffee break. There are no comments or questions. Well, before the proceed to the coffee break, I would like to give the floor to Mr. Saifulin, who is the head of International Academy of Technical Sciences. Yes, please. The floor is yours. Please take the floor near me.
Good afternoon, everyone. It is my distinctive pleasure to congratulate Dusan Bayat, head of Serbia Gas, Director General of this company, with an important event, an important development. He was elected. He has become an elected member of our Academy of Technological Sciences, and he is now awarded with a special medal for his merits and achievements in development of oil and gas technology. Congratulations. Well, here you have the ID member of the membership card of our academy. Now you are a proud card-carrying member of the club. Here is the commendation letter from the Academy of Technological Sciences. We congratulate. We are grateful to Dr. Dusan Bayat for his input and contribution, and a gratification certificate for the fruitful cooperation with Gazprom. Why are we writing this? Because we are a member of the International Business Congress. And thank you, Dr. Aksutin, for helping us, for supporting us and endorsing what we do. And we are trying to do our utmost to make our input as helpful as possible. So here's the testament to the cooperation between Russia and Serbia. And we are looking forward to continuing and maintaining our relationship with each and every member of the Congress. Dear Congress, dear participants, we have a 15-minute break.
Продолжим нашу работу.
Dear colleagues, please be seated, and we are continuing the work of our committee. All right, you got 2 minutes, and then we start.
Уважаемые коллеги, продолжаем нашу работу.
Colleagues, and we are continuing, and now it is my pleasure to give the floor to Roman Shaykhutdinov, Deputy Prime Minister of the Russian Republic of Tatarstan. As far as I understand, you will have a co-rapporteur with Iskander Bariev, the first Deputy Dean of the Innopolis University. Thank you, Dr. Aksyutin. It's a pleasure to talk with you today. I think you have a great venue here to discuss all the relevant issues. I hope I'll be concise as possible. I was instructed to act as a sort of a visionary. As you probably might know, we've constructed an entire city, Innopolis. It's a satellite city of the city of Kazan, of the Russian city of Kazan, where we have an experimental regulatory framework where we test and do the trial runs of many technologies, promising technologies, and act as trailblazers. We test driverless cars. We provide experimental digital MBAs and many other MBAs related to energy, artificial intelligence, and other promising fields. On top of that, we have an entire cluster of startups that work on developing Russian national software and dual cyber systems. So I think that at today's session, I'd cover some of the matters that are very pertinent to the topic of our discussion today. I think we've met last February, if I'm not mistaken. And as I was preparing to talk to you today, I decided that I will focus on 4 major drivers. and some trends and phenomena that would be the most relevant going forward. I think that the crucial thing it's the competition between the two models of the political and economic models of development. We're talking about the centralized and decentralized models of political and economic order. It's important and it's relevant to our discussion today because it will impact the technological solutions as well. Another important trend is the fourth industrial revolution, which is to a great extent a data-driven trend, and I will dwell on it a bit later. But then again, come to think of it, which countries will join the revolution in literal and figurative senses of the word? Who would enjoy the benefits of this revolution? Who will advance it forward? Who will create the high value-added products and the ever-increasing technological disparity? We see how technology actually promotes inequality. We see how many technologies, or the lack thereof, actually pushes many countries to the margins of the technological progress, and it drives the greater inequality in terms of purchasing power parity, and in a purely technological sense of the word, it's a driver of inequality growth. And the fourth major trend is something different. I can cite the infotechs as an example. It's a pioneer. It's a trailblazer of its kind. I remember that, well, way back when I worked in Moscow and I was launching one of their systems, but I digress. The fourth trend is the trend towards establishment of national platforms. The recent conference, the Digital Transformation of Industry, Prime Minister mentioned that there will be 15 national intellectual centers will be created, and they will pursue the technological knowledge and advancement, and their core goal would be to develop national software expertise and other competences. And some of them, things like ASTRI Linux, Word, SCADA, 1C and SCADA are examples of this trend. So this is the kind of a systemic, too big to fail software that will be developed there. So that is the direction in which we're going. So we all know that there have been 4 industrial revolutions. First were the steam engines that gave birth to the oeuvre of the great economist Adam Smith and his economic theory. It was the steam engine, which was invented in England, that to a great extent shaped the face of industry of the century when they were invented and of centuries to follow. The second industrial revolution was the invention of the conveyor and electric engines. So it was the serial production. It was the ability to produce things in great quantities. And only one name comes to my mind. It's Henry Ford. Today, anything that can be produced in series, that can be scaled up, has the potential to conquer the world. Just take a look at the workflow and processes in high-tech companies and countries, and you will see the, so to speak, proof of concept. You will see the technologies that can be replicated and scaled up and adopted in other countries. The third industrial revolution was synonymous with automation. It took a long time to happen. So what was the direct consequence of automation? It was the emergence of a totally new concept of data. And data allowed many other things to evolve and to come to fruition. And the gist of the fourth industrial revolution is the autonomy and flexibility. I'm not sure that the fourth industrial revolution is the apt word, since today many people speak of the fifth revolution that is taking place in countries like Japan. Well, I took Uber, or in another case it should be Yandex rather, as an example, as a poster child of this fourth industrial revolution. So it's the digitization, the digital transformation, the efficient use of resources. So they make products as lean as possible. Here's a quick video of how the office desk evolved as the years went on. You see how many gadgets have been disappearing, or rather supplanted and replaced by apps, by devices, by gadgets. We often see how analogous or analog workflow has evolved and then disappeared, and eventually it all can be fit within a single laptop. The peculiar feature of what's going on today is that any user, any person can analyze your data. And I think the best people to analyze out there are the financial experts. If you have a look at your digital profile in a bank, you can tell almost anything about a person. German Gref, CEO of Sberbank, once showed me my digital profile, and it literally took all my data, extrapolated and guessed that I have 3 kids, that I'm married, that I'm a public civil servant. So here we have on screen the quote by a famous science fiction writer, William Gibson. It's been quoted time and again. And it's quite symbolical that after the February 24th, it has a sort of a dual meaning. The future has already arrived, it's just unevenly distributed. When he said it, he meant that the future is unevenly distributed among the different technologies, among the people within countries. But if we look at it today, we'll see a completely different picture. But we would understand that it is unevenly distributed between the countries or among the countries, meaning that some countries will never be part of this fourth industrial revolution. There always will be countries that will depend upon certain technological solutions. The solutions would be vital to them, and that would be foreign solutions. There will be one single company, which I will mention later on, and the entire world effectively depends upon the operation of this company. Here's the crucial thing. Over the last 2 years, we are seeing a true quantum leap in the country. The digital economy national project has been articulated, and within it, 12 sub-projects have been determined. If you look at it, this project was the most difficult one. the strategic session, the underpinning, the academic underpinning of it was shaped exactly in the University of Innopolis, located in our republic. Well, these technologies mentioned on the slide are what we call a wall-to-wall technology, something that embraces and covers everything. And they all are geared towards the same thing, to increase the labor productivity. And we can make a distinction here. First, the labor productivity within our work processes nationally, and then the labor productivity that we can sort of export, helping out other countries to adopt the technology and increase their labor productivity. So if we look at the digital technology and the state of it in Russia today, you will see that it has a significant share of, how should I put it, foreign element. I think the quantum technology is the most complicated and complex technology of all mentioned here, and wireless technology would be perhaps the simplest of all mentioned on the slide. But I think that the most important component of it is the big data. Right now, we have, in terms of a point of reference, a sort of a coordinate system within which we can analyze and process big data. But we are the underdog here. It's the US and China which are the biggest competitors who compete the fiercest. Oh, and by the way, I think that we can clearly say that all of these technologies, apart for perhaps quantum technology, which are just making their first baby steps, all of them are very applicable. Well, we haven't invented the quantum engine just yet. Well, I think that right now quantum technology are mostly used in security systems, and Infotex will perhaps correct me if I'm wrong. We've tried to, well, we've tried that with Sberbank. But it's more of a theoretical question. Is the Earth round? Well, it is. What difference does it make for, an average guy like you and me? Infotex. Well, yeah, it has to do with the security systems and encryption keys. It's all about the speed of processing and cracking the passwords. Innopolis. Well, the point I'm trying to make is that it's not a mature technology yet. It has some academic interest, but it has no real application so far. Anyhow, I would say that there are 6 stages of digital innovation development. And different companies and different countries will go about it at a different pace and in a different manner. Here are the 6 stages, the way we see it, as the digitization, deception, disruption, demonetization, dematerialization, and democratization. I think the first 2 are the most difficult ones to live through, as it were. I mean, the stage 1 is when you have analog data. It's on paper, on some physical medium, and you have to digitize it. And every time when a new technology emerges, there's always a question that kind of invites itself. Do we have to do this? I mean, we have a working, a viable solution. Remember the digital cameras? Like, we had film, it worked fine. Why do you fix what's not broken? That's the kind of thing that you would ask yourself. Okay, so then you digitize it. And then the next stage comes. The 2 things are crucial at this point. First, it's the critical amount of data that is being processed. And second, it's being passionate about it. Passionate and visionary. So you need this kind of hyper enthusiasts, people who will push the process forward to make it happen, who would believe into it. Take Rosatom, for instance. They have an exercise, a drill, under the calculate a socioeconomic effect for a given technology and a given company, I want to dwell a bit on this slide. Well, first off, I want to express my gratitude for the support of the Advanced Engineering School. It's a new project. Several days from now, there will be a huge brainstorming session on the advanced engineering schools. There will be 15 of them. Each of them will be sort of gravitated towards the orbit of 15 big companies, manufacturers. Some of it have to do with software, developers, aircraft, machine building. So each school per each industry captain. The idea is to create the biggest convergence possible between the academic pursuits and the business needs. So they will be working on what we call the frontier challenges, the most difficult academic and business challenges that exist today. And most of them actually will be based in Innopolis, in Kazan. I will introduce my co-speakers, and we do have a very a pool of talents, a formidable pool of talents. All right, so the name of the slide is The New Feudalism. So what does this mean? Remember way back when the first industrial revolution was taking place? People who invented steam engines were opposed fiercely by feudals, by sovereigns. In Spain, the work on steam engines was classified, even though Spain at the time was richer, was a wealthier nation than the United Kingdom. It was competing with Netherlands. So it all repeats itself right now. When the companies are abusing the technological competitive edge. When you are registering your smartphones, you tick the box whether you share your data or not. Well, that's a pro forma exercise. They will collect your data regardless of whether you tick the box or not. So this is what the new feudalism is about. It has several trends. It's the country-to-country disparity. It's the different level of access between countries to the advanced technology, and the disparity among the companies that produce something. So the companies that collect the data turn themselves into commodities, and companies that can process this data took the precedence. Look at this relatively short period of time, 2008 to 2018. Saudi Aramco is it's an oil and gas company, but all the rest of them, all remaining 7 are in one way or another digital companies. Now, I want to draw your attention to a chip-making company, and I know that China is pushing hard to produce its own chip crystals. And I think that if our country wants to retain its competitive edge, although I know that Infotex rep was saying that the chip makers have a long way to go, we still have to go in this direction. There will be huge demand in Russia and abroad. The market capacity in Russia alone is 12 million devices per year. Each of them requires at least one chip. So just imagine the amount of the market in monetary terms. Okay, so here we go, the 3 stages of digital transformation. Those are the stages that we've distilled from our personal experience. Most of them are related to business processes, but some of them are related to technology used. It all starts with monitoring platform. It starts with the situation when data is accumulated in sort of a data sets. But even before that, we have a sort of a crude data, if I can put it this way. And so we collect them, we try to analyze the deviation, we try to see some macro trends. And I mean, you can have all kinds of sensors. You don't need the information about how many flies flew through the workshop floor. Well, I mean, you can track this, you can identify this, but you need something actionable. So you can either do a kind of a quality leap or a quantity leap. So what we're trying to do is whether we're trying to make more money or we're trying to spend less. How do we spend less? We cut the costs. We create efficiencies. How do we make more money? We create added value. Well, take the gas fields, and there is a community just beside the gas field wherein people work at the gas field. So if we put everything in a digital form, what are they going to do? It works the same for the Navy. It's like one community or one small town per one submarine. So they're intrinsically linked. If we break this link, you have to replace it with something valuable. So we are collecting these data sets and we are trying to analyze them. Then we try to do some sort of reporting. We try to analyze them through the use of AI to employ some sort of an intelligence platform, and then we move on to the third stage, which again has to be split into two sub-stages. I think the most vivid example is Tesla or any assisted driver system. It's rather an autopilot or some sort of a driver-assisted autopilot. Oh, by the way, in Innopolis, we have the first of a kind regulatory regime. We have 16 fully autonomous vehicles that drive around the city. So we're trying to collect the legal and technological practice to see how it would work, how it would be employed in real life. It's crucial for ensuring the technological sovereignty and perhaps exporting the technology at some point in the future. We are very thankful to Gazprom for their support, and I want to give the floor to my colleagues.
Какая цифровизация?
And they will speak in greater details about some specific cases that Innopolis worked on. So enough with visionary stuff and out with it, in with some real cases. We've got actually students from Innopolis here and his professor who will talk a bit more. All right, so in a nutshell, I'll give you the brief description of the cases that we've worked on. Something that we think has a greater effect on the digitization of Gazprom proper. That's the project that dates back to 2012. It's an information support system that helps to diagnose the state of pipelines. So it basically gives you a second pair of eyes to visually inspect something. We are employing machine learning and machine vision systems. We use the data collected by robots equipped with sensors, and they inspect the internals of pipelines for cracks and mechanical damage. So we can reduce the time necessary for calculation or assessment of the state of the pipeline by a factor of 20. But time cost, this reduction in time of operation is just half of the story. We also can improve the rate of processing the machine-generated reports by a factor of 100. As you might understand, when we collect more data, it inevitably generates a greater probability of error. The second project that we've discussed for a while today, it's the software system for geomechanical modeling. So this was the import substitution system. We effectively substituted some of the Schlumberger and Halliburton solutions. So we are often asked, what are your students working on? So Ilnar, a guy to my right, was the person who not just coded the program, but who transferred the functional capabilities. Colleagues, my name is Ilnar. I work in Innopolis, and I am part of the developing team. So, in my work, I focus mostly on the system, of the geomechanical modeling system. Actually, ours is a huge crew. It's not just the two of us. Most of us have IT background or math background. The team is scattered across Russia, and it's crucial to link all those people into a single team, an actual crew that would work as one. And then the goal for such a team is to deliver on a project as soon as possible and at the greatest quality level possible. So the key thing is to understand what's the success metric. You can't just have the specification and then you produce something and you just go through the checklist of specs, and that would be it. Often we see the evolution of the demands of our customers. As the project develops, the demand develops. And one of the areas that we are working on is exactly this, the agility and the adaptability of the technology. So this project is dedicated to geomechanical modeling. We can model the drilling processes, we can analyze and model the drilling and development wells. And as I wrap up, I can tell you this. Innopolis is an experimental sandbox, if I may. It's a great place for IT people to work in, to test new ideas, to put them to test them in practice. All right, so what we're trying to do now, we are trying to create a single platform that can tackle all the geological tasks. There are many promising technologies such as digital twin for the research laboratory that will drive down the costs, that will reduce the idle time, that would improve the competences and training of the staff, that will make the process of complex experiments more transparent. This is something that we are currently working on. And we can verify that the numbers that we are quoting here are actually deliverable. It's something that we can accomplish in practice. The next promising project is the development of a digital platform for managing business processes. The business processes in geology and development. We worked together with Tatneft, and we worked with Gazprom, Urengoy. The goal was to streamline the business processes through end-to-end digitization, to improve the efficiency of gas field development, no, oil field in that matter, to improve the efficiency of the technological mode selection, and to to streamline production based on certain economic and technological metrics. My colleague has mentioned Innopolis as a sandbox, and it is indeed a sandbox where we do the trial runs of many autonomous vehicles, where we try out Face ID systems, the 5G coverage, and IoT things. We do have driverless taxis. We do have driverless trucks. We even have an unmanned bulldozer. So that's a universal solution for operating in enclosed areas. We have mobile underwater unmanned vehicle. We have heliplanes, all kinds of things. So that's what we are working right now in terms of robotization. And as my colleague mentioned, the Advanced Engineering School, I wanted to chip in and say that we have some specific tasks. Our customers, rather, have some specific tasks, and they are often very complicated. They are often actually go beyond the scope of academic performance and go beyond the IT tasks. They are purely engineering tasks. So what we're trying to do is to create a toolkit for IT specialists, for the academia. Well, the thing is, we don't have the tools to develop national software. We simply don't have analogs for systems like Jira, to GitHub, and to many other sort of software for software developers. So they can produce something domestically, but they cannot do it using domestically or in-house based tools. So take Gazprom, for instance. You have some IT needs, and you have some IT people needs. You need trained experts, and this is what we are going to deliver. That's exactly the essence of existence of such advanced engineering schools. It's been already said that we will work on the frontier tasks, the most challenging ones. It's the 2022 project. We will be able to train over 1,500 staff members for Gazprom, who will be able to tackle the most challenging of your tasks. And that would be it from me. Thank you.
Спасибо, Роман Алексеевич.
Thank you very much, dear colleagues. Thank you, Mr. Shaykhutdinov, Mr. Bariev. Thank you for a somewhat philosophical intro. But in fact, as for interaction with the Innopolis project, we've been working together since 2015 onwards. We started with a pilot project that I believe was a success. It was the very first of a kind. It wasn't perfect from the very beginning, but as a result, we managed to pursue our goal, and by doing so, we also have opened up the gateway to further interaction in different areas. As for training in HR issues, we understand that within the topic that we discussed today, availability of the workforce would be critical in terms of development of a company as such. Therefore, employees that would be not just the classical IT experts, but would have the necessary competence in the specific areas is yet another stream we actively discuss. And the third point that I'd like to make, and that relates well to what you were saying, well, of course, it's not just specific to different companies. There may be a lot of specifics within different departments of Gazprom. So what we've been discussing today is indeed very true. We're preparing a unified program and curricula that would take into account the needs of the students and would set the right bar. I understand that this is what we all need, because if we want to be able to speak the same language, to clearly understand the terminology and identify the goals specifically, that's the only way to proceed. Dear colleagues, are there any questions to our presenters? No questions. All right, excellent. There was just a small request on my side. I do come to Innopolis from time to time, and we do talk to the guys. But my request was I want it to be a real university, and if it is to be a real university, you're supposed to have students. And that was my explicit request, to bring students to this event, to make sure that the interaction we have with our partner universities is proper. We have partner universities, and we really want it to be not just some way of support that we're rendered to universities, but actually doing R&D in our interest, and our colleagues showcase a great example of that type of cooperation. Thank you once again. And we move on to the next presenter, and that is Konstantin Slanov, Business Development Director, Cometa Digital Technologies. And the topic of presentation is digital adaptation, everyday work in a constantly changing environment. Konstantin, the floor is yours. Good evening, dear friends, dear colleagues. Today, we decided to take a look at digital transformation from somewhat unusual viewpoint. Whenever we talk about technologies or digital solutions, we normally assess specific metrics of business processes that those decisions are affecting, be that speed, transparency, performance, and so on and so forth. But frankly speaking, we hardly ever assess how technologies change our perception of our daily work systemically. How do they impact our regular workday? So let us try and analyze what is the impact of technologies on a regular workday in the office. So the most frequently asked question or cry out for help would be, I keep working more and more, and the workload is only increasing. So it may seem that the interfaces are getting more convenient, the communication process with colleagues is getting faster and smoother, but nonetheless I have a constant feeling of burnout, and this is vividly felt in many companies, and the corporate surveys only confirm that. And workload and excessive workload may be a commonplace for employees depending on the company and the project, but we think we have to make this question more specific, and it should be phrased as follows. I can't complete the work I've started, and I keep switching between different tasks and information, and I keep accumulating the volume of started but not completed tasks. And indeed, the research and the surveys conducted by various laboratories and universities in the area of cognitive functions demonstrate considerable reduction of an ability to focus and to dive deep into the goal you are trying to focus on. That's very typical of modern employees and office workers. So even a typical pattern of reading has been recognized. We normally read the first paragraph, then we scroll down, read the paragraph in the middle, and then scroll it down to the very end of the article. And the key reason for lowered ability to stay focused is the fact that we are constantly present in the information flow and a constant change of an information context. This is something that has been carefully researched in terms of neuroscience and the work of neurotransmitters and the way that dopamine is produced by our body, and those are the natural mechanisms that keep forcing us to acquire more and more information and act more. So this constant shift in context, in focus, is happening increasingly frequently in our daily lives as there are more and more technologies coming to our life. More systems, more communication channels, more pressure, more notifications coming on every day. Trying to stay online, to be available 24/7 creates for this information noise that we need to learn how to manage. Otherwise, our brain becomes really hasty and impatient, and it gets really difficult to focus. And as we lose our ability to focus, it is becoming increasingly difficult to plan our work schedule. There are more and more stakeholders involved in our daily schedule from the side of the company, which results in considerable losses of our work time and the productive time we spend at work. So what is the way to gain back your workday and control over your work schedule? Well, we see two types of tools available here. That includes organizational tools and technological tools. And we believe that the leading role in terms of digital adaptation should be played by HR services and IT services. It requires a synergy of soft skills, an understanding of human psychology, and proper understanding of technologies. So if we focus on organizational tools, then the first step would be to properly update the hygiene of communications, especially now when all the ways of communications are available now. So quick messaging does not necessarily mean frequent messaging. We were all taught when we were children not to distract adults when they are busy. But whenever we communicate virtually, we frequently cannot know whether our partner is occupied or not, and by sending our messages, we may keep partners distracted. Let's say for engineers or IT developers, it is critical to be able to focus and not be disturbed. Effective online meetings, the same good old rules of doing online meetings: prepare the agenda carefully, prepare the materials, manage expectations, and this is something that should also be communicated offline. I would say over the last 2 years, it has become a common joke when there are Zoom meetings and the contribution of half of the participants to the meeting is hello colleagues and goodbye colleagues, and that's as much as they do. And multitasking does not apply to communications and should not be applied to communications. I sometimes catch myself thinking or even acting, or I keep thinking that I should probably check my mailbox and answer a message while I'm present at an offline meeting. That is, of course, a bad thing to do and keeps you out of focus. Personal effectiveness techniques in a good way. So I'm not talking about Instagram coaching. I'm talking about the actual techniques that people need to be reminded of or even trained. What's the right way to plan your work day, to split the work into the right pieces, to stay focused and be able to get distracted properly, and how our cognitive functions fluctuate in the course of the day, what are the tasks best to be pursued in the morning, and what are more suitable for the second half of the day. So that's a way to manage your informational context, and this is something that we need to pay attention to and be mindful of. Now, as for technological tools, let's try to take a peek into the future, although the majority of the solutions that I'm going to talk about are already being implemented successfully and used successfully. The first and most obvious one is Do Not Disturb mode. That should become available at the majority of corporate tools, and that is namely about a possibility to manage informational flows and the informational impact that you can get. And here I can see a certain transition towards new redesign of corporate apps that would take into account those developments and perception of cognitive functions of a human being that have to be taken into account in terms of daily work. Personal digital assistance is something that can serve as a filter regarding informational flows and could help you stay focused, or again properly distract from an assignment and slicing it into proper pieces that can be processed using AI. Smart calendars that would allow you to plan for those goals based on a large amount of factors, depending on the priority of the assignment and the way the assignments are related between one another, and taking into account the calendars and available calendar spaces in the calendars of other participants. And the final point on personal analytics. Just like we get analytics on the screen time, statistics that you get from your smartphone. So here you can keep track of what you are spending time on in the course of a day. Some suggestions and recommendations could be made on what is the best way to make most of your time. So in the future, you would be able to identify some trends, the impact of external factors or some seasonality factors, whether there are any changes to the workload during the holiday season, and whose holidays are most impactful for other colleagues, and so on and so forth. And in conclusion, just a few statements. Being constantly present in the information field and swift change of context negatively impacts our ability to stay focused and to manage work effectively. And this is a new area that we need to learn how to manage gradually as new tools emerge. We need to take a fresh look on our old habits. And with active supports of HR and IT departments, it is necessary to change corporate culture and your personal habits to be able to adapt to a changing environment. And in terms of tools available, they should provide users with means of protection or ability to just turn the whole information noise off. And in the future, they should only help us improve our cognitive abilities. And that brings me to the end of my presentation. Thank you very much, Konstantin. That was indeed a very interesting and fresh look on digitalization. Looks like we have forgotten about the human being in all our talks about digitalization. All the advantages the digital technologies give us shadowed away. Any questions or comments, colleagues? If I may you please comment? We always keep a human being in mind, and the problem that our colleagues have raised is indeed important and a big problem, and it was most evident in the time of the pandemic, while we all worked remotely, and afterwards there was a rapid increase in information sources and channels of getting information. And the worst thing that people started doing was writing emails on every possible occasion. Well, I personally would have around 200 to 300 emails a day in the time of pandemic. And at least half of them could easily be avoided. And this is when we noticed in the time of pandemic what is going on, why people are so inefficient in their performance. And also, additionally to those tools and psychological and physiological approaches that you've presented, I wanted to share two things that have shown themselves well in terms of reduction, the damage that we incur as we try to multitask too much. The easiest one is we test and develop some solutions that would allow us to use a shared informational space by uniting several systems, let's say mailbox, messenger, contact book, so that you do not have to spend extra time on those transactional expenses, so to say. And the second solution is more systemic. That is a necessity to develop data management tools and platforms and create flexible end-to-end architecture that would allow us to seamlessly transfer information between different systems so that you wouldn't have to log in separately into different systems, especially if there is a separate password and login. It is killing a lot of your time. So those are the two streams that we are making good progress on. We receive good feedback. So I guess this is something worth paying attention to. All right. Well, I have very positive memories of pandemic. I would say that the paperwork was dramatically reduced, and it was conditioned by the remote access possibilities. But since it wasn't happening all at once, by step, we have identified a lot of backup, and we've reduced the paperwork by 30% for sure. And this is when we were able to focus on the main things, on the core, and we're somewhat nostalgic recalling our remote work time. Because back then, the performance, the efficiency of our work increased. And when we got back to the office from the remote work, this is when we encountered a whole avalanche of emails. And I guess it well compensated for everything that we cut off while we were working remotely. So, the experience was very different on different sides and places, I would say, in terms of interaction, because it was very clear from the very beginning things that we can do without and we can't do without. But again, remote access was provided gradually, step by step, and at a certain moment, I remember a person responsible for remote access who told me maybe it's time to stop providing remote access rights, and then the security service helped us, so we decided it's time to pause. But under their current daily work, those issues that you comment on are absolutely valid. I guess everyone would agree. Any further questions or comments? All right. Thank you very much. And the final presentation for today will be delivered by Alexey Apolonsky, Director of Projects Execution Department at Rosgaz-Shelf, and the co-presenter is Alexander Komarov, Head of Automation Directorate, also at Rosgaz-Shelf. And the topic is special software for hydraulic, electric, and production control system simulation and analysis, development, experience, capabilities, and potential usage. The floor is yours.
Distinguished colleagues, good afternoon. Today we would like to share the information on our work that we carried out and been carrying out for a certain time. And today we would like to share the results. But first, a bit of the background information. Our company, Rosgaz-Shelf, we work on the subsea production units. We create the infrastructure, and the infrastructure is a big word. We work on installation, on the transportation, and then the commissioning of the new high-tech devices for the subsea production. And the production of the technologies of devices is the core of our work. Our main client is Gazprom, and we work in Yuzhno-Kerensky field. We work with SPS equipment delivery. Part of this equipment was created by our company. Surely we work with different partners and subcontractors. We have international partners. Back in 2019, we understood that we have a major problem in this creation of equipment. Sometimes our team try to manage the whole process of the production of the devices from the very beginning of the engineering, but we have lots of different issues. For example, we don't know how special specifications are created, how special parameters are achieved. And usually we receive just the very abstract answers, because there are some certain calculations and certain R&Ds that cannot be disclosed. So sometimes we cannot really check the technology and the parameters. We can only believe that it's really true. And it's a big problem for us, especially because we understood that some parameters could have been better. And we couldn't really understand how we then can forecast the usability of this equipment in the future. What we would do if we would need to change something. So, because of this challenge, we decided to have a new vision of the whole process of the equipment creation. So we decided to be more independent. We drafted the requirements, the initial data, and the main assessment criteria. But this we created so-called framework for the creation of equipment, and this was the first step for the creation of our own independent software for hydraulic and electric systems for the SPS. So we started from the very practical goal. We needed a solution that would check certain criteria, and then this data could be used for the creation of the equipment. First of all, we started with the search for trustworthy partners in the scientific field, in technological field, because we needed the coding specialists, the developers, those who would understand the physics that stands behind the software. Our main partner now is the Department for the Hydrodynamics at the Polytech University in St. Petersburg, and we also partner with Moscow Physical and Technical University. We work on electrical and communication system calculations. This work started back in 2020. And now we have the software solution that is called Atlas Digital, which is a cross-platform solution. It works both with Windows and Linux operational systems. This platform enables us the modeling of the hydraulic, electrical, and communication systems for the SPS. So we now can calculate the hydraulic schemes, have the data for electrical systems, and calculate the communication systems. And this platform can be used directly for the calculations, but also it can work so-called in reverse way. So if we already have some solutions, some purposes from our from some proposals from our subcontractors, we can then check their solutions and see their calculations. This software was really created by the top experts and professionals in the field. We already have scientific research and scientific papers created based on those developments for this particular program. This is a unique platform. It has no equivalent abroad. Every part of it was strictly verified. So we checked all the calculations that we obtained through this platform. We then checked those calculations using other softwares, some niche softwares that can be used for this purposes. For us, it was very important to prove that our calculations are as good as those from other softwares that has already the reputation and has been used before. I would also like to mention that during the creation of this platform, that now this platform can not only be used for SPS, but also in other fields. Now our key task for the development of this software is the scaling up of this project. So we really want our platform to be used not only for subsea production units, but also in other fields, not only related to oil and gas. So now we try to identify the goals and how our program can be used in our fields. And now I want to give the floor to my colleague, Mr. Komarov, the head of automation department. He'll show you the interface of our program, and he'll also share the vision for the development of this software. Good afternoon, distinguished colleagues. We already discussed the digitalization a lot, and we've been talking about the general vision, and now I will show you our solution, that is one of the practical examples of the digitalization. As it was already said, this program was built on purpose in order to have the possibility to check the data obtained from our foreign partners. In the subsea production units, the main element is the hydraulic system, and some values, some parameters are being used throughout the life cycle of a certain development field. So this is why we need to have the data for the cable cross-section and all the necessary parameters. And nobody actually wants to pay twice and wants to have all the values in advance and have them checked and verified. The hydraulic system have two main, and here in the software we have two modules for the calculation of the hydraulic system parameters and the electric system. Initially, we saw three main possibilities to check the baseline data. First of all, we could change the existing software so that our parameters could have been checked, or we could use the open source software, or draft our own software. And back in 2019, 2020, we decided that the third way is the most optimal, so that we could make it our intellectual property, everything beginning from those calculations, mathematics behind the software and interface. Every software can be assessed by two parts, front end and back end, so the interface and the algorithms behind the interface. So I'll try to show you the interface, the possibilities and functions, and also what to expect next. So the program is really user-friendly. It can be used by everyone. So you see how the interface looks like. So this is the software that is quite common for similar programs, nothing new. So every person can use it easily without some special preparation, some special training. Well, on the next slides, I'll try to show you the main functions. Those are the standard functions that you can find in any simulation software. But as I already said, everything was drafted by our company. We used the C coding. We wanted it to look user-friendly and so that everyone could use it easily. So you see different nesting possibilities. So on the first picture, you see the hydraulic management. On the second graph, you can see the communication system. So every such algorithm makes all the calculations very difficult and complex. So what we can check, what can we analyze? We can analyze both the ideal and elastic fluids. We can do the unsteady calculations. Probably we will later add new functions as well. For example, for flow sim calculations, so that the user could use different methods for the calculations. Here you can see the possibilities for the visualization of the results and reports. You can choose and select the data to be visualized, and you can also have the dynamic visualization. For us, it was very important to have such a clear visual solution as well. We have also the possibility for optimization solution. We are not only looking at the data that's already there in a particular unit, but we also want to look at how a particular technology can be made more optimal. And here you can see the how it can be done. We have the single objective optimization and multi-objective optimization. You can see the mathematics behind the algorithms in our solution. Now we have 2 PhD papers being written based on our work. This work was curated by the top expert in the field from a university named after Bauman. And what I can say, both front end and back end top quality. Half of our work was dedicated to mathematics and back end, and another half front end. So both are equally good. We have good libraries that are enough to calculate hydraulic, electric, and communication systems. But we want to enhance the functionality of the software. And we have now two main directions for our work. We work with the Department for Hydrodynamics of Bauman University, and we test in the hydraulic analysis module. And we try to enhance the functionality and do the beta testing using the possibilities of Bauman University. We do the debugging of this module. As for the electric and connection analysis module, it will be the solution that was provided by St. Petersburg Polytechnical University is better. So probably based on their solution, we would have this united platform for both high hydraulic analysis and electric and connection analysis. As for the long-term perspective, we have qualification of the simulation software, and now we are working on the module for the flow state analysis, both for single-phase and multi-phase flow. We are now in the research stage of this process. We try to estimate the cost of this module, and we believe that the creation of a model will take about 3 years. And now About the software qualification, the simulation software, I believe that every university works on some simulation software. It's all about the verification of the results. First, we wanted to certify our software by the company DNV. It's one of the top companies that work in the field of subsea production. We also work on software. We have the recommended practices for the qualification procedure, DNV RP 0513, but this company left the Russian market, so we decided to make our own classification procedure. And this is the third step in the creation of our software. So first we assessed the risks. When we assessed the skills of the team that's creating the simulation software. And now the third step, so how we should really make the qualification procedure. We have now created the conceptual model for the qualification procedure. We looked on all the possible limitations of the software, and this is kind of a document that could be used by the developer. The second part is the description of the methods that were used. The special topic is the mathematics behind the algorithms. Because mathematically, the task is very difficult because we have three main components, and we have nonlinear equations there with more than 5 subtasks that are also being described by different equations that can be solved differently. Surely, some methods are more effective and others less, so this is why we need to look at them all to check what are the best solutions. And the third step is the comparison between the experimental data and the calculated data. In Russian regulatory documents, we haven't found anything like this, so we took as a base those guidelines, those best practices by DNV, and we used it to create our own qualification procedure. So this is the brief overview of our program. Thank you for attention.
Thank you, Alexey. Thank you, Alexander. Any questions? Oh, we have a question here. Thank you. We, as people from the academia, are very interested in this. Could you share a couple of words about the licensing process? How long is it? Yeah, I think Iskander asked the right question. It might be, the corporate standard or the industry standard. So it begs a question. Is it any key or not? And the second thing, well, for certain technological processes, you could apply the ready-made solutions. Answer. Well, some of it was, to a great extent, shaped by corporate standards. Question, so through life itself. Answer, well, pretty much. We do some calculations, especially for hydraulics, using this technology. Then we use the methodology that was created in-house. We see whether there are any points of contact, any convergence. Question. No, I'm talking about the licensing models. I mean, anyone can buy it, not just a company, like an individual. Answer. I have no answer for you. I'll talk to you later. I'll follow up. Question. You said that you let the universities to do kind of a test run. Well, let me tell you this. We have a program for this. The thing is, there must be a community around the software, a piece of software, a community of sort of early adopters, people who would test it for free, basically. Well, we have an association of university teachers, so they have a sort of a test run unit using which they can test run almost any kind of piece, any kind of software. And let me tell you this, they've test run over 15 different pieces of software. Well, it's a difficult process, and many foreign companies used to give out trial software for free just to get people hanged on their product. So we're trying to replicate the practice. We're trying to pass on these trial versions for over 100 of universities so that students will try it out for you for free. Follow-up question. Let me comment on the answer. Well, this is a very apt and proper suggestion, and we would be very happy to meet you halfway. I think the very idea of giving out our software to any laboratory that would be interested in using this is great. I mean, take the Bauman University in Moscow. It's one of the top technical universities in Russia. We have graduates, we have postgraduates from there, and Ilnar mentioned this. So, first, we have to understand that, yes, the product was qualified and verified. Yes, the declared performance and specifications have been verified. And yet, without actual feedback from real people, from students or somebody else, we are blind. We cannot see where are the drawbacks, where are the shortcomings, what can we improve upon. So yeah, the feedback is the meat and potatoes of any piece of software. So thank you for the offer. We would be gladly accepting it. Question. And the piece of software that you are developing, is it compliant with the Russian requirements, the legislative requirements? Answer. Well, this is the totally made in Russia product. Question. Well, it's, there are second and third level of requirements. Answer. Well, it was written in the C language, so it's completely no strings attached product. Question. Okay. Are there any requirements to transfer the data between the modules of the program? Answer. Well, you have to understand this. This was a kind of a secondary tool, like a temporary makeshift product, something to rely upon while we addressed a specific task. So now we are thinking on how can we make it evolve, how can we apply it to something else, how can we fine-tune the concept. We would be extremely happy and joyful if we would be able to find another applicable domain. So this offer of yours to somehow pass it on to project universities, to get the feedback from students, is something that we are very much welcome. We would do everything possible to make it happen. And a follow-up answer. Well, the thing is, we are currently polishing the product, fine-tuning this and tweaking that. And if we get actual feedback, for instance, somebody tells us, we need data in this or that format, we'll be happy to meet you halfway and give you this data. Question. Well, I was asking about something different, about the ability to integrate it into something else. So you mentioned the data that will be passed on and transferred to the project documentation to do some kind of mathematics or analysis. So the question is whether you looked into this aspect specifically or not, or was it an afterthought? I mean, in our effort, we often face some very strict requirements about the data formats, the amount of data, the size of data. So that was my question, whether you've looked into this aspect or not, whether it's even possible to connect and integrate your software into something bigger. You mentioned the simulation that you are using. So would it be possible to use this mathematics for the simulator in another domain? Well, but you answered this. Answer. Well, partially, yes. Question. And the second question is the security matter. It's no coincidence that I asked whether it's a Russian product or not. It's a crucial thing for us. Well, colleagues, do we have any questions or comments? There being none, we have listened to the last speaker on the list, and I sincerely want to thank all the speakers for the reports prepared, for their remarks. We said that from the very beginning. We do understand, we do see how the situation unfolds, and we will go back to it time and again, given how rapidly the situation unfolds, given the fact that we're living in the time of great opportunities, the way I put it. This is the moment where markets and companies can evolve in a different way, and to use this window of opportunity, I want to thank the organizers, the secretariat of the IBC, for this splendid organization, for this great welcoming hall. I want to say thank you to all the participants and to the interpreters for doing a great job. And I will see into when we can schedule the next event. It's a great pleasure that we actually can see each other face to face, you know, in a real in-person meeting, which is a no small thing. All the best and every success to you. And colleagues, one more thing. I'm sorry. Housekeeping remark. Family photo. It's a crucial thing. We need to make it. Thank you.